So, you've probably heard of synthetic data, right? Basically, it's fake data. It's designed to mimic the real thing. For the longest time, though, it was kind of like a blunt instrument, not super precise. But that is all changing, and fast. In this explainer, we're diving into how we're learning to actually control the fake data we create. And trust me, that is a very big deal. Let's get into it.
Okay, imagine this scenario. A hospital is sitting on this enormous data set of patient records, and hidden somewhere in all that data are patterns that could lead to a cure for a horrible disease. But, and this is a huge but, sharing that data is a massive privacy nightmare. You've got patient names, you've got sensitive medical histories, it's a total minefield. So, what do? Do they just keep that potential cure locked away forever just to protect privacy?
And that right there, that is the classic data sharing dilemma. It's this constant tug-of-war between how useful the data is and how risky it is to share. Now, for years, the go-to answer has been, well, let's just use synthetic data. But here's the thing, the solution itself is getting a major upgrade. We're moving way beyond just simple copies into something a lot smarter.
So, let's break down that basic trade-off, right? You've got real data, which is super useful, but also super risky. Then you have basic synthetic data. It solves the risk problem. Hey, it's anonymous, but it introduced a massive new problem. You had almost zero control. Imagine going back to those hospital researchers and saying, hey, here's your safe fake data, but sorry, we can't make sure it's fair, and we can't guarantee it even follows basic medical rules. You can see how that would make the fake data, well, pretty useless a lot of the time.
Okay, and this is where things get really, really interesting. To solve this whole control problem, two brilliant new philosophies have popped up. And I want you to think about them like this. You have a choice. Do you hire an architect, someone who draws up a perfect, detailed blueprint before a single brick is even laid? Or do you hire a guide, someone who helps you navigate and react to the terrain as you're actually exploring it?
Let's dive into that first approach, the architect. The whole idea here is actually pretty simple and intuitive. If you want a specific kind of synthetic data, you should write down the rules, the blueprint, before you even start to generate it. And this approach has a name. It's a framework called CUTS. And what it does is it lets the person who owns the data give the AI a list of really specific rules before it starts making anything. It's kind of like telling an artist, hey, paint me a picture of a crowd, but I need you to make sure there's an equal number of men and women, and absolutely no one has purple hair. You set the rules, and the AI has to follow them, to the letter.
So how does the architect actually pull this off?
It's a two-step dance. First, it looks at the real, private data to learn all of its deep underlying patterns, the secret sauce. Then, it takes that blueprint of rules you gave it, and it fine-tunes itself, tweaking and reshaping its output until every single one of your rules is met. It is all about precision, planning, and getting it right from the start.
But, what if you don't have a perfect blueprint? What if you need to be a bit more flexible? Well, for that, let's meet our second approach, the guide. The guide doesn't bother with planning every single detail ahead of time. No, instead, it takes a super powerful general-purpose AI and just steers it in real time while it's creating the data. And this is the core idea behind a method called REL-DDPM. It starts with one of these incredibly powerful AI models called a diffusion model. You can think of it like a master sculptor who starts with just a random block of marble and then expertly chips away until a masterpiece appears. REL-DDPM basically trains one of these AIs to be a master data sculptor. Then it uses these little things called controllers to guide the sculptor's hands as they work, without ever having to retrain the artist from scratch.
The guide's process is all about being efficient. Step 1, you train this huge, powerful, general model. Just once. That's it. Training is over. Then, step 2. Whenever you need some new data, you just activate a specific controller for whatever your goal is. Like say, hey, make more examples of this rare side effect. And it just guides the main model in real time. It's unbelievably flexible and fast.
And this really lays out the two different philosophies perfectly. On one hand, you have the architect, CUTS. That's all about precision. You write the blueprint first, and the model is custom built to follow those rules. It's the best choice when you have to enforce strict, non-negotiable rules. On the other hand, you have the guide, REL-DPPM.
That's for when you need to adapt. You steer a general model on the fly. It's the star of the show when you need to be flexible and react to new conditions without starting all over again.
Okay, so we've got two pretty brilliant ideas on paper. But do they actually work in the real world? Well, researchers put both the architect and the guide to the test with some really tough challenges.
The architect's whole promise is precision, right? So researchers gave Cutts a classic, difficult problem. Generate a synthetic dataset that is provably fair, but also accurate enough to train a really good machine learning model.
The result? It was a clear win. And it all came down to this one number, 2.3%. So, what does that actually mean?
This is the really crucial part. Researchers compared the architect to the best method that came before it. They forced both of them to create data with the exact same level of fairness. And what happened? The data from the architect produced a machine learning model that was 2.3% more accurate. Think about that. It gave them perfect fairness and better performance. That's a huge win.
All right, now it's the guide's turn. Its strength is being flexible and controlling things on the fly. So the challenge here was to take a general model and, without any retraining, guide it to create data that had way less bias based on a sensitive factor.
And wow, the results here are just as impressive. This chart shows the amount of bias in the data that was generated. That bar on the left, that's what you get with the next best method. Now look at the bar on the right. That's what happens after you apply the guide's controller. The bias is just crushed. It's a dramatic drop. This shows just how incredibly good these little controllers are at steering the AI toward a much fairer result, all in real time. The researchers who built the architect really put this whole breakthrough into perspective. They said that this work shows for the first time that it is in fact possible to allow for diverse customizations without significant sacrifice in utility. In other words, we've finally broken that old trade-off. We can have control and we can have quality. We don't have to choose anymore.
So, who's the winner? The architect? The guide? You know, the biggest takeaway from all this research is that this isn't a competition. This is really about the dawn of a whole new era for synthetic data.
Yeah, the future isn't about one single winner. It's about having this powerful new toolbox. Data scientists now have different tools for different jobs. They have one for high-precision, rule-based work, and another one for flexible, on-the-fly guidance.
So let's wrap this all up. The main takeaway here is that we have two powerful new tools. The architect is your go-to for when the rules are strict and you know them up front. The guide is your adaptable navigator for when you need to be flexible and react to things as they happen. And both of them are absolutely vital. They're helping us move beyond just fake data and into a new age of truly useful synthetic data, the kind that can help us build a safer and more equitable world.
And all of this leaves us with a really fascinating, maybe even a little scary final question. As this technology just gets better and better, we are getting closer to a point where we can create pretty much any data reality we can think of. So the question we really have to start asking ourselves is, what should we build?